Good evening once again, ladies and gentlemen, and welcome to our 14th Annual Opportunity Banquet. We are very glad to have you all here tonight, and we hope you've all had the chance to meet with the wonderful companies we have here. My name is Chat Gamba, the Vice President of SWE, and this evening I have the chance of introducing to you our keynote speaker, Kirk T. Steidel. He is the Director of the Michigan Department of Transportation, also known as MDOT. Appointed in 2006 by Governor Granholm and again in 2011 by Governor Snyder. He graduated from Lawrence Technological University with a degree in construction engineering and currently serves on the College of Engineering Advisory Board there. He has built quite a reputable career for himself since gaining his Bachelor of Science degree. In 2014, he was the chair of the Transportation Research Board Executive Committee, as well as the second Strategic Highway Research Program Oversight Committee for TRB. He is a national leader in the development of connected vehicle technologies and was the 2014 to 2015 chair for the Intelligent Transportation Society of America Board of Directors. He is also a member of the Intelligent Transportation Systems ITS Program Advisory Board to the U.S. Department of Transportation. Currently, he oversees administration of a variety of multimodal transportation programs and projects that range from aviation to the Zilwaukee Bridge. Last and most importantly, he now oversees MDOT's over $4 billion budget and is in charge of the construction, maintenance, and operation of its state highways and bridges in a department with over 2,500 employees. I know this is a whole lot of information at once, but by this time you can probably tell that this is quite a remarkable man to have in our presence. And it is with great pleasure that I introduce him to you tonight. Please help me in welcoming our keynote speaker for the evening, Director Kirk T. Steidel.
Well, good evening, everybody. Hey, hello. The lights are kind of bright here, but I can still see you. Good evening, everybody. There you go. All right, we're in. I would like to echo something that Dr. Soji said to the industry partners that are in the room. And I sit on a number of industry boards, advisory boards. Thank you, thank you, thank you, thank you. Universities, colleges of engineering can't evolve and can't move forward without your input. They have to know what's happening in the industry. They make better students. They make better employees for all of you. So I know it's Friday night, and you're here at a career fair, and there's probably 3 other things that you probably think you should be doing. But for the future of your profession, this is where you need to be. And I want to thank all of you for doing that. I know exactly the things that are going through your head. If you're a parent, you're thinking about this, what I got for the weekend. If you're a father that's got some project going on tomorrow, you're already doing your list of what you got to get from Home Depot. Yeah, there's a couple people that grimmed, right? So there's lots going on. So if we could have one more round of applause from the students thanking the industry partners, because that is such a great commitment by them. So please, students, thank your partners. The other thing that strikes me is the mix of engineers in this room. Civil engineers, yes, we mentioned those first, sorry. Because you other ones don't. Mechanical engineers, electrical engineers, computer science, technologists, all of you. The presentation that I'm going to talk about tonight and what I'm going to show you has a piece of every single engineering discipline in it. I know that many of you, some of you are still students, you probably don't know other people in the other disciplines. Maybe you do because you had calculus together or you had physics together and you work side by side, but then the last 2 years you start drifting apart. And then you graduate and you go on to industry and all you hang around with is the same kind of, I hang out around with civil engineers or mechanical engineers or electrical engineers. That's That's how the fields kind of work. Well, the whole thing's getting turned upside down. Now I can tell you, so from that introduction, I've been the department director since 2006. That's one of the longest in the country. About 2005 or 6, we started a conversation with the automotive industry about the future. You know, these connected automated cars. What's all this going to mean? And the joke was that the interface between a civil engineer and a mechanical electrical engineer was the tire. That was the interface, right? Civil engineers, you build from here down. Mechanical electricals, you build from there up. Now, I know you mechanical engineers have some other things that you call civil engineering marvels. We call them marvels, you call them targets. That's okay. I would encourage all of you to get to know the other people in your industry, the engineering industry. Now, as I said, the first couple of meetings I sat with, for 6 months, we talked past each other. We used some of the same words that meant completely different things in our industries. I had one of my colleagues that was chairing this committee, and he was from Utah. He had been around a long time. He was from Utah. He's not from the Midwest. He's not from Detroit. After 4 months, he said, "What does OEM mean?" Now, everybody in this room, I hope you know what that means. Everybody in this room gets that. But here's a guy that he's been a civil engineer. He'd done some great things in the West, had no idea what that meant, right? So we really started to communicate. And it took about a year before we really started to understand what each other was talking about. And frankly, in many cases, people were going back 20-some years before they had really reached outside of their own branch of engineering. So I would encourage all of you, no matter where you're at, if you're a freshman or you're in your senior part of your career, look outside of your little branch of engineering. Frankly, there's a big world out there. It's a big world, and we're all part of it. Now, we as engineers think the world revolves around us. Okay, it does. The rest of the world just doesn't know it yet. No, just kidding. There is a lot of stuff that's going on all outside of us, and we sometimes run in a parallel world. How many of you have had discussions with the legal profession? Not personal legal. I'm not talking about personal legal. I'm talking about legal from your perspective, not because your company got sued. But what does it mean with your engineering across different engineering modes? What does it mean from a legal perspective? How about the medical fields? And how about insurance? How about public policy? Any of you had any discussion in public policy in the last year? I'm a civil engineer. I'm a professional engineer. I do public policy all the time. I never took one single class in public policy. And the more I learn about people that I hire in the legislative area, neither do they. But that's a whole nother story. But we're all engaged in public policy, right? Every time we hear something that's going on in the government, that's public policy. We could, and we need to, as engineers, influence public policy. Now, I'm not going to get up here and give you a political speech about that, but I want you to think about that. There's problems on the front page of every newspaper, every day, every month, every year, that are going to get solved by engineers. But the engineers got to be able to stand up and say, this is the public policy piece we need to fix, and here's how we're going to fix it. There's an engineering solution for it. You've got to get engaged in that conversation. You might want to run for public office. I did that once. I was elected twice to a city council. It was a nonpartisan ballot. It wasn't paid. Well, I'm sorry, I got a per diem of, I don't know, $300 or something. You learn a lot. And I would encourage you to think about your school board or think about your local community. They need your expertise. Get involved. Maybe sometimes you'll run for elected office. I work with legislators both in the State House and the Senate, and I wish I had more engineers because I know engineers think logically. Politicians don't think logically. They think like this. It's all over the place. Drives me crazy. It's like, look, I need to go like this. I've learned to kind of move with them. but we need more engineers in that as well. So before we really roll into this, I have one more personal question for all of you. And it doesn't matter if you're a freshman or you're later in your career. Where do you want to be in 5 years? What's your career goal? The only thing that is guaranteed, hopefully, is that you're going to be 5 years older. All the rest of it is up to you. So if you're about ready to graduate and you're 21, hopefully in 5 years you're going to be 26. That's about the only guarantee you're going to have. What you do in the middle of that, you could just prod along and let people kind of shove you, move you around. Or you could say, you know what, this is what I want to do. Here's where I want to go. And make those changes to go do it. All of us, all of you and all of us in this room have the ability to go do something else. You've got an advanced degree. If you don't like the job you're in it, don't stay there. Go do something that you like to do, because your career will go like this. All of you that had 25 plus years in your field, raise your hand. Right. Didn't it go by like this? Wasn't it just last year you were sitting right here as a graduate, right? Or maybe as a freshman? It goes by that fast. And I don't know about you, but I know what I'm doing 5 years from now. It has nothing to do with public policy, let me tell you. Might have to do with a beach. But I'm serious. I really want all of you to think about that. What do you want to do? Because your career will pass you by if you don't participate. So let's talk a little bit about the future of transportation and technology. This fusion is happening. This is where all of these fields are coming together. Now, I threw a little wrinkle to the organizers today because I changed my presentation like half an hour before I walked in at the hotel, because I was reading Crain's Detroit Business, and this was the quote. Oh, wow, it doesn't show up on the whole screen. This was the quote from Bill Ford yesterday. And yes, General Motors, folks, it's the rival across town. Here's his quote. Every single thing is changing, from what's propelling cars to the ownership model to artificial intelligence, 3D printing, autonomous driving, even the way we finance. And I would also add insurance as well. It's all changing. Now he goes on to say, hey, there's a great fortunes to be made. The point is, what we know today is not what's going to be here in the future. Now, are we going to get there overnight? It's going to take a while. It's going to be, I refer to it as a pretty messy transition period. But let's talk about why a civil engineer is so interested in technology and automobiles of the future. Let's flip that next slide. So we have a saying in Michigan, and frankly, it's almost every state. I don't know for sure, but I would guess that the Indiana DOT has something similar. How many traffic deaths are acceptable on nation's roads, or in Indiana? Give me a number. How many do you think is, so we have about 30,000. What's an acceptable number? Anybody? Nobody wants to say a number. Somebody, Dr. Soji, what do you think is an acceptable number? Yeah, 0, right? Because the next question was going to be, okay, so let's say we can get that number to 1,000. That would be great. We went from 30,000 to 1,000. That would be a tremendous piece. But what if it's your family? Then it has to be 0. There really is no number other than 0. Now, I know my mechanical engineering friends are out here saying, yeah, okay, but physics and this and that. Okay, but there is no other goal other than 0. Are we going to get there? We got a thing in the middle of that, but always moving it. Thank you. That has to be the goal. We have to have the goal. We have to push to 0. Go ahead and flip the next slide. Here's some numbers associated. That top one is the 30,000. Actually, last year, it was 40,000. It had been going down, 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 down. There was a bunch of people patting themselves on the back going, oh, we're doing great, we're doing great. Fatalities are going down. You know what? The economy picked up across the country. Vehicle miles traveled kicked up. And we started killing more people in crashes. Okay? Maybe we haven't figured it out yet. Of course, if we could get everybody in the car to stop texting and stop reading your email and stop being distracted, maybe we could turn that around again. Now, I don't think that's going to happen. I don't think you can put that genie back in the bottle. I don't think we're going to be able to turn technology around that way. I think we've got to advance technology even further if we want to change that trajectory and start getting to zero. So I'm going to talk about vehicles. There's two types of vehicles. These get interchanged, connected and autonomous vehicles. So an autonomous vehicle, you've heard of the Google car, right? Some of the folks working in General Motors may know of their autonomous Chevy Bolt. Great cars. It's like having a laptop, not hooked up to the internet. Laptop's really, really smart. So now you take that laptop and you connect it to the internet. It's exponentially smarter. Or, professors, what happens if you have a classroom full of really smart people and nobody can talk? You have some really smart people. That's good. They'll all individually grow, but that doesn't help the whole class grow. So when the class starts talking to each other, with your permission, or when you connect your computer to the internet and you start talking to other computers, you increase that knowledge of the whole network significantly more. These two run on parallel paths. Eventually, they will come together. That's where we will see the safety benefits. There's going to be safety benefits of just an autonomous car. Car can go down the road. It knows it doesn't bump into anything. Some of you are old enough to remember the first time that the little Zumba thing came out. Remember, you used to just let it go in your living room and it would vacuum everything until it got caught in a corner and it couldn't turn around anymore? Some of you have Alexa at home, and Alexa's connected. Did you ever ask Alexa to play Jeopardy? That's pretty cool. If you haven't ever done that, that's pretty cool. My daughter taught me that. She's a biosystems engineer. Last time she was home, she said, hey, let's play Jeopardy. I said, what are you talking about playing Jeopardy? Yeah, Alexa will let you play Jeopardy. Anyways, it's connected. It's exponentially smarter. That's what's going to happen. That's where the lives are going to start to be saved. Here's a timeline. These are kind of hard to read. For the automotive folks in the room, you're probably involved in some of the stuff on this end. Parking assist, construction zone assist, lane keeping assist, a lot of things that are already on cars, out to the future, out to the edge, highway pilot, fully autonomous systems. Some of those systems are absolutely amazing. So I'm going to spend a little time right now to talk about this paradigm shift that we're in. I'm going to break time into three groups. One is the past. That's the past decade, living up to today, and then the next 10 to 30 years, and then beyond that. Okay, let's take the next one. So historically, all the civil engineers in the room, this is what you do. You look at the historic trends and you say, where did people start at? Where do they go? What's the distribution? Where do they move on the network? What choices did they make to take a car, to take a bus, to take a train? What's the route assignment? You say, okay, great, we have all that information. It's logically going to progress in the same manner, and that's what the projection 20 years out is going to be, and you build it, and you're all great and happy. And it's worked fine for the last 80 years. But we really are moving towards a paradigm shift where the whole mix of vehicles and the whole mode of travel is about to change. Connected automated vehicles, electric vehicles, travel patterns unlike those in previous years, and we'll talk a bit about those in just a minute. There's probably significant infrastructure changes that are needed. And you can't really predict what's happening. It's happening all around. All of the different fields are beginning to work together. It's tough to see down the road to say, this is exactly what we need to do 10 years from now or 30 years from now. But let's consider, go ahead. Here's what's happening. So the automotive engineers understand the Society of Automotive Engineers levels of automation. 0 is your basic car from a couple of years ago. 5, that's the car that you get in the back seat and take a nap. There's no interaction with it at all. It knows where it's going. That's level 5. Folks, that's a long ways away. But one's on the road right now. There's some 2s. I've ridden in a 4. I've actually ridden in a shuttle that's a 5, but one on a long distance that's a 4. Those levels of automation are going to continue. They're not slowing down. The really smart engineers in this room are going to help move all those companies through that. But on the other side of that, there's also this movement towards shared services. What I hear is all the millennials don't want to buy a car. They all want to ride somebody else's car. I don't know about you. I have 2 millennials at home. They both wanted a car. But that's the general trend, is more shared services, increased driverless shared services like transit, commercial vehicles, shuttles, mobility on demand, rideshare. The whole demand side of that is changing as well. So what does all that mean? It means driverless vehicles served in urban and rural transit riders are going to increase, and they're going to increase mobility for people that don't drive today. So think about that. We have people that don't drive that are now going to be on the road. So what's that do to traffic volumes and congestions? Ride sharing is going to certainly increase to be more driverless. We have a fleet of General Motors Bolts running around Detroit. We've got a number of other test vehicles running around, a couple other small companies. They all have drivers in them right now, but when the company feels comfortable, it will be up to them to pull the drivers. There's a really cool pilot going on right now between Ford Motor Company and Domino's Pizza, where in the Ann Arbor area, they're delivering pizzas with a driverless Ford Fusion. So the Ford Fusion pulls up and it's all decked out in Domino's, right? And the windows are all darked out so you can't see in it. The back window, there's a keypad on the, whatever was that called, the C-pillar, the last one at the end. They send you a text and say, this is, your pizza's arrived, and here's the text number. You punch in the text number, the window opens a little bit, out comes your pizza from a pizza oven. Now you can't see in, but inside the car there is a driver. They're not driving, they're watching the car. But to the person that picked up their pizza, it was a driverless car that showed up to bring them their pizza. Think about how that changes. That's absolutely amazing. So think about weather conditions. Think about the deployment. So if you're on the shared services side, what does the roadway look like? If you're on a freeway, do we start to have lanes? Your big urban area, you get to Indianapolis and all of a sudden you start to see the inside lane. It can only be here if you have an automated vehicle. You're certainly going to be safer. We don't know exactly. Don't know how that's going to come in. Think about the very first time that you ride in a non-demonstration vehicle, and where do you think that'll be? I can guarantee it won't be in a snowstorm, and it's not going to be on a busy road. So if you're thinking that your first trip is going to be down in some interstate through the middle of Indianapolis, that's probably not your first ride. That might be interesting. It might be fun, but it's likely to not be that. So let's move on. So let's go back. Sorry, I talked about this. So now let's go ahead, one more. Let's go to the future. So this says you're 20-something, right? I'm just going to pick 2050 just because it's a nice round number and it's out there a ways. I don't know. Some of you, like me, aren't going to particularly care how I get around in 2050. I'm just going to be happy to be getting around. I'm going to be depending upon some of you freshmen in here to make sure you're doing a good job of getting me around. So there's certainly going to be, it's going to be an interesting time for transportation planning and forecasting. There's a whole bunch of public policy questions that come into play when you think about the deployment of an automated vehicles. What's the energy policy in the country? What's the cost of energy? What's the land use policy for the community you live in? What's the parking charges in the community you live in? So I go to Chicago a fair amount of times. It costs $50 a day to park your car. Well, what if you lived in the suburb and you rode in your autonomous vehicle? First of all, you have an hour drive in, which is all billable. You can work all the way in. You get in, you drop it off, and you know what? It only cost me $5 in electricity to drive into work. But I'm going to park it for $50. I don't think you need calculus to figure that out. You just send it home and then say, come back and get me at 5:30. Okay, so it costs you $10, you save 40. It's great. You get a bottle of wine when you get home. That's good. Maybe, you know, have a nice dinner. So public policy and parking, energy policy. How do you incentivize that if you want to incentivize it? What's the cost of that vehicle? There's some great engineers here that are going to help develop those, and you're going to drive down costs because that's what you do, drive and drive and drive. Well, what if you get to this autonomous little pod that doesn't cost $50,000 or $80,000? What if it costs $12,000? Some of you might say, I don't want to share it with anybody. They might have a cold. I don't want that. In fact, I might want a red one and a blue one depending on what my mood is. That will determine how many cars are on the road. So let's talk about a model that we might use going forward. Everybody has seen this, right? In the last 2 months, we've seen this, this model from NOAA, and it projects with very little historic data. It says, here's this cone of uncertainty of where it's going to go, right? And we all kind of look, we've got relatives here or there, and you know, what's it going to hit? And as we saw with the last one that went through Florida, look, it's going to hit Miami. Oh, no, it's not. It's going to go over here, right? So if we take that and we project it out to 2050 and say, well, here's the cone of uncertainty, right? It could be that connected automated vehicles, nope, go back. Connected automated vehicles are 60% of the vehicles on the road, okay? It could be way up there, or it could be they're only 10%. It could be that everyone owns their own, or it could be that they're very low vehicle ownership and we share them. How do you make a decision for that, right? So now think of your transportation department that's tasked with deciding what the freeway should look like next to you, and there's the variables. And you're building a freeway that it's going to last 30 years. By the way, automotive engineers, that's what, how many cycles of cars, right? We've got to decide what it's 30 years out. I want you all to figure out 30 years ahead too. And we'll build it and let it last. So there's that cone. So let's go to the next one. So we start to narrow it down, right? So how do you narrow it? Take away some of those variables. What do you start to do to try to zero in on something? And clearly, the closer you get, the better shot you have, right? Except maybe if you're the weatherman. Right? The weatherman has trouble predicting what's going to happen tomorrow afternoon, particularly when you live in the middle of the country. Indiana's not much different than Michigan. Just if you want the weather to change, hang around for 10 minutes, it'll change, right? How many times have you had snow, rain, sunshine, all in the same day, right? So here's some things that are happening on a national level that we're working on from a public policy perspective. Some education, some scenario planning, some mixed fleet operations. We have to always keep in mind, what's the public interest? When you work for the government, our charge is public interest. Make sure that we're doing what's right for the people of the country or the state. I can't tell you how many times I've had Governor Snyder tell me at the end of the day, we have to do what's right for the people of Michigan. That's what we have to do. And he basically says, okay, push those political folks out of the question. What's right for the people of Michigan? There's another big one here. Number 5, I'm sorry, is workforce development. How's the workforce going to change? First of all, you're developing them, building them, fixing them. What's the repair shop look like? But then what about the people that are displaced? What about the truck driver? Now we have an autonomous truck. What about the truck driver? What about the taxi driver? What about the Uber driver? You know, in 1910, there was a whole industry that made big buggy whips. 1920, nobody made buggy whips anymore. It's all the buggy whips in the world. It's going to change. We've got to think about that social impact, and it's about people. What's the impact of people? And we've got to figure out how do we bring them along as well. So I'm going to, this next part of this, I'm going to talk to you about some of the things we're doing in the state of Michigan to try to squeeze that cone of uncertainty down a bit. There's a number of tests that are going on, and I'm going to give you just a glimpse of some of them. Actually, I thought I took that out. Take that one out, too. So there was, in December of 2006, there were 4 bills passed in the state of Michigan. Prior to that, there was only a bill passed in California. That was, in my view, very, very onerous. It was typical California. It was a big overreach by government, way too far into the regulatory scheme. I heard from somebody in Washington that said, well, I said, you're not going to adopt that, are you? And they said, well, it's the only one that's out there. Nobody else seems to have an opinion. I said, well, okay, well, we'll give you another opinion. So we passed these. They've been modeled in, I think, about 20 other states at this point. But first and foremost, if you have an automated vehicle, you can drive it on any Michigan road, anytime, anywhere, no special driver's license and no special operating license either. Now, you can't buy one, but if you can operate it on any road. It allows for truck platooning. You see some truck platooning going on here through Indiana. You'll see some of it if you're in rush hour in Indianapolis. It's called tailgating, actually. It looks like truck platooning. Truck platooning basically just changes the following distance. Now, real simple, all of you know that, the aerodynamics put two together certainly is an advantage for the following truck. That number is actually about 10% fuel efficiency. The front vehicle actually gets a bump as well, about 4 to 5%. So there's a company that sent a plan into me and the state police colonel in Michigan and said, this is what we want to do. By law, we had 30 days to either accept it or reject it. We accepted it, so now it's legal to do truck platooning by this company in Michigan. So we've got an education piece to tell the general public, look, when you see 2 trucks that are 30 feet apart and they're going down the freeway at 65 miles an hour, that's actually legal and it's okay. And they're probably safer than the 2 that are apart. The second piece allows for on-demand automated networks. Now that's a driverless Lyft and a driverless Uber. You can operate those today on the roads in Michigan. Now, I got to tell you, when we were having this discussion in the spring of 2018, my son was a senior at Grand Valley University, Grand Valley State. He and a buddy were at my house on a Saturday night in April. And I was trying to get my head around this because I had auto companies saying, we want to do this, we want to do this. And I'm thinking, wow, we're going to have a driverless car as a shuttle. It's going to be a driverless Uber. This is spring of 2016. So I looked at the 2 of them and said, hey, if a driverless Uber comes to pick you up tonight, will you guys get in it? They both looked at me like I had 3 eyes and said, it got here. Okay, I get it. It got here, you're right. They had no qualms about it. How many of you would get in it? If it came to your house, how many of you would get in it? Great. How many of you, no way? Right. Okay, what you can't see is the age barrier. I won't stereotype anybody. If you're over 40, you don't get it. You're over 40, you're not getting in. Under 40, you just accept it and away you go. Over 40, you actually read all of those things of what privacy things you're giving away when you click the little bottom. Below 40, it's like, get me to the app. Come on, fast. Anyways, so those are allowed. And it could be by a manufacturer. It could be by, so it could be, a manufacturer like General Motors or Ford or Toyota, or it could be the manufacturer of a control system, which would be Google or Apple or somebody else that comes along. It creates the American Center for Mobility. I'll talk about that in a minute. And then the last piece is it has protections for mechanics. And this one's not been replicated anywhere else, but think about the mechanic when you take that vehicle back in. And it specifically says if you repair it to the original manufacturer specifications, you don't have any liability. If you tweak it, yeah, you just bought it, and you bought all the liability. It's one thing to tweak an engine and get a little more horsepower out of it. Some of you in the room had some vehicles in the 60s or 70s where you could crawl inside the engine and you change it a bit and get a little more horsepower. Yeah, that's one thing. If you start changing a safety system, that's a whole nother ball of wax. This said, you repair it to the standards, you're okay. I know General Dynamics is here. We do a lot of work with the Tank and Automotive Research and Development Activity Center, our engineering center, I'm sorry, in Warren, which used to be the old tank plant. And we've done 2 testing of truck platoonings with military vehicles. The first one was 2 years ago on Interstate 69. That's Interstate 69 way up there, almost up by Canada. And then just 2 weeks ago, we did another one. In fact, it was that far truck on the right. I was riding in the back, and it was completely autonomous. We rode from Port Huron, Michigan, across the Blue Water Bridge into Canada. Yes, in a military vehicle. We invaded Canada. That was interesting. We had no guns, which that's rule number 1. Turned around and came back. That was amazing. You're sitting in this big military vehicle with all the armor and all the rest of it, and it moved itself. The driver was like this, hands off, feet off, steering wheel adjusted, moved. It followed right behind the vehicle in front of it. Now, if you think about that from a military perspective, and I know there's some in the room that have a lot more knowledge of it than me, it's about sending supplies to troops without putting troops in harm's way. Military is probably 5 years ahead of the rest of the auto industry and what they're doing. There's some just amazing things going on. Let's go on. At that other school up north, oh wait, I'm not in Ohio, sorry. At the University of Michigan in 2015, we opened this thing called M-City, and it is a 32-acre complete autonomous village with attributes that 35 different attributes that an autonomous vehicle would encounter on a road, like a roundabout, like concrete roads, asphalt roads, concrete barriers, steel barriers, gratings from the Mackinac Bridge, railroad crossings, dirt roads, tunnels, canopies, blind curves. And it's connected to the College of Engineering so they can do research. They started off with 16 leadership circle members, big companies that came in and said, we're going to help support that. Part of that goes towards research, and then part of it goes research at the engineering level, and part of it goes to research at the company. They now have about 65 companies. They have a level below that called an affiliate member, and this thing is getting used almost 24 hours a day. So it was February of last year, Ford tested the first autonomous vehicle in a snowstorm, and they learned a ton. What happens when snow packs on the LiDARs? You get this bouncing effect. I should ask the Raytheon people, they probably know more. It really messes up the LiDARs. It's helped advance the research significantly more than had they not done that. Now, up until that point, I'd been on the stage with one of the chief designers from Google in a number of national conferences, and he would get up and he'd show all the Google things, and I said, wait, that's Mountain View, California. It's sunny and 78 every day. You bring that thing to Michigan and show me it works in January, and then I'll say you got a business product. And the other thing he said was, I just need a good paint line. I don't need anything else, I just need a good paint line. Every road in Indiana have a paint line on it? Yeah. It does in Mountain View, California, I guess. I reminded him that 50% of the roads in the state of Michigan are gravel. Some of them are 2-tracks in the Upper Peninsula. How's that autonomous car going to work there? Yeah. So let's move to the next one. So M-City was successful, but it's small. We moved on to the American Center for Mobility. As I said, it was in that law, that package that created that, or that was signed. It created this. This top piece, what you can't see underneath it is it's the old General Motors Hydromatic plant. I know there's some GM folks in the room. You may remember that, the Hydromatic plant. At one point, it was the largest manufacturing facility under one roof in the entire world. Before that, it made B-24 bombers at the beginning or the middle of World War II. Interesting tidbit, if you don't know about that war effort piece. At that point in time, about 1942, the U.S. and Boeing was building one 747 a month. And the government came to Henry Ford and said, is there something you could do? Could you use this new assembly line technique that you have, and could you make those faster? In fact, we'd like you to make one a week. And Henry Ford took on the challenge, and he said, you know what? I'm going to build one a day. The government kind of laughed at him. In the end, they built one every 55 minutes. You talk about the arsenal of democracy. This is where Rosie the Riveter was. They were pumping out airplanes, one every hour. And so here's a local politics piece. It's about a mile-long assembly line. Well, the end of that assembly line went into another county. 1940s were at war. The county treasurer says, hey, that's a finished product coming out of there. I'm going to tax that. Henry Ford said, you want to bet? And he turned the assembly line. It went like this, stayed in the property, opened the doors, they got the pilots in, they started the engines, they turned, and they flew off. They flew into the other county and the airport, and he just kind of waved at the treasurer and said, how's that? But this whole facility was built in the 1940s, and at the very top where the blue part area was US 12, still is US 12, and it was four-lane divided freeway, and it has interchanges that would handle 30,000 people at shift change every day. Well, the building is no longer there, because after GM bankruptcy, this is one of the facilities that was liquidated. It became a 300-acre parking lot. So we're never going to need that capacity again. So we've moved all the traffic over, and we've taken that other high bankment and 3-level interchanges, and we've leased it over to the American Center for Mobility, and they're in the process of building a 2.5-mile high-speed loop that looks just like every attribute you would find anywhere in the country. That has the final paving course starting next Monday, and it'll be open here in about 2 weeks. It currently has founding members. The first ones that came out were AT&T, and then Ford, and then Toyota, and now Hyundai. There's one more that they haven't publicly said yet, and we're waiting for the company. We've already actually cashed the check. Cashed it in June. I don't know what they're waiting for. And then 2 more that are coming that will be big anchors as well. And then there is about another layer of about 50 suppliers under them that are continuing. That's their next layer that they're going to be continuing as well. So it's moving very, very quickly, and it's coming out of the ground, and we expect this site is going to be complementary to M-City. M-City is doing research. This one is going to do validation testing, which means it's going to run something thousands and thousands of times. In fact, the robotics engineer from Toyota said, we're going to push them to the limits. In fact, we may crash. We're going to do it here instead of on the road. It's one thing to make a claim that you've driven 1 million miles. Okay, well, on what kind of roads and in what kind of situations? So just think about driving from here to North Platte, Nebraska. You just drive back and forth every day. Okay, you can rank up a lot of miles, but so what? It's all the freeway. It's all the same. You don't encounter any of the same scenarios. You don't really learn a lot. So total miles on a vehicle and testing is not important. Not important at all. So we expect a lot coming out of here. Let's go on. That site is listed as one of the 10 US DOT's proving grounds for automated vehicles in the country. We just had a symposium during a larger conference last week and brought all 10 of these together, plus about 10 other worldwide test facilities as well, so they can collaborate instead of compete. One last thing that the law created was the Michigan Council on Future Mobility. And you can see a host of companies across the bottom, although over on this end, my GM folks, it does say GM over here. And their charge is to report to the legislature and administration on barriers that are in the way of technology, right? A report once a month or once a year, and help identify how we move this forward. So I'm going to give you the last couple examples of what's going on. Southeast Michigan, there's a number of connected roadways. These are outside of Michigan, or outside of Southeast Michigan, outside of Detroit. That 3-4 county area is about 5.5 million people. It's where all the traffic is all day, every day. There's congestion, there's safety problems. These are instrumented freeways that have fiber running underneath them. They've got roadside units that communicate in direct short-range communication. And they're not ubiquitous. We set them up for whatever company happens to be working on a particular area, and we, so if we're down by Dearborn, and we're on 984, it's Ford's input as to what goes there. Along 696 goes by the GM Tech Center. We've got some others there. And then our goal is by the end of next year, we'll have 350 miles, and by the end of 19, it'll be at 500 miles, and I suspect it will probably be well over 1,000 a year after that. Now, how are we doing that? Some of it is roadside units alongside a freeway, some of it's the communications. But one of the things that we learned is a test that we did in Macomb County, that's kind of northeast of Detroit, and we did it with General Motors, and we were testing the red light violation warning, which means you're approaching a red light and you all look at the sidewalk countdown counters, don't you? You look and you say, oh wait, the little walk sign says I got 5, 4, 3, and hurry up. Yeah, we don't really like you to do that, but that's what happens anyways. So in this one, we instrumented the signals, and we send out the signal to phasing. We send out the geometry of the intersection, and we send out what's the signal phase in each lane. Because you might have a right turn lane, a left turn lane, so the car needs to know what lane it's in, and we need to know what the signal phase is going to be. What General Motors did was integrate it right into the Cadillac CTS. So as you drove through the intersection, it would tell you the light was going to be green for this long or yellow, and if you were approaching it and it was going to turn red, it gave you a warning. Now, it just didn't go beep, beep. It flashed red on the dashboard. The seat vibrated. That definitely got your attention. So from that, we actually have changed our traffic signal specification, and that's the traffic signal we are putting in every single time we put in a new traffic signal. You might think, well, those are really expensive. Well, they are in the research phase, but when you move them into production, it was less than 10%. And that includes the fiber optics to connect all of the signals. I've just had a meeting last week with 15 of my counterparts across the country and said, this is where we got to go. If we're going to instrument, that's how we can go. We all change traffic signals every single year. Why wouldn't we spend up to 10% more to put in ones that actually last for the future? All right, the last example I want to give you is a partnership we did with 3M. All of you have seen this left sign, right? And you all go, oh, 2 miles ahead. How come traffic's backed up already? How do I get out of here? Yeah, okay. So that sign is in place to tell you, the driver, what to expect ahead. And then we have to have a whole bunch of signs like the Burma Shave. Wait, there's only about 4 people that know what Burma Shave is. What those signs look like going down the road. So you've got to have the series because you can only interpret a little bit as you go. What we did with 3M is we said, I wonder if there's a way to use infrared and machine vision and open a communications channel between that sign and the vehicle. Because you're talking to the car. Now you're talking to the operating system. Go ahead, change it to the next slide. So when you drive down the road, you'll see this. It looks like a QR code. It's not. It's a 2D barcode. And you'll see them on a couple of construction signs. We had one area that we did this in. But what you can't see is that upper right corner. At night, and it doesn't have the barcode on the bottom, that barcode is embedded in the sheeting. So as the infrared hits it, it sees the barcode. It can see it further down the road than you, the driver, can. And if we go back a slide, you'll see on the right side, it gave general information. Okay, it had the latitude, longitude, and it says here's what it said. But what it did was prove we have a communications link. Now we can have it say a lot more. We could have less signs. We could provide a lot more information. Of course, my friends that wear tinfoil hats say, oh, wait. Now you're going to be telling this is going to be the key for the UN when they come in for where all the concentration camps are and how to take us to all those spots. Now, you didn't get that, but that actually is a concern. There are people that are absolutely positively convinced that I put up signs to help direct the UN when they invade. It's a crazy world we live in. So let's go to the last slide. And, nope, one more. All right, how many of you grew up with any of these three? How many of you grew up with the Jetsons? I did. Love the Jetsons. We're getting pretty close, aren't we? Except when George pushes the button and then the car folds up into a little briefcase and walks in. That'd be really cool. Mechanical engineers, work on that, please. And then how about who grew up in the era of Terminator, right? This guy right here is an autonomous shuttle until Arnold rips him out and drives it. And then, frankly, my favorite is iRobot. Think about iRobot. If you've watched iRobot, the most stressful time, Will Smith is driving along, and all of a sudden the robots are jumping out of the car in front of him, and they're like climbing all over his car, and then the car says, driver, prepare to take over. That's like the level 3 handoff, level 3, level 4, back to the driver. Wait. I got to fight robots. How can I be driving at the same time? That's where we are, folks. All of those are starting to come true. We're all going to see them. Hopefully we're all going to see them. Some of you are going to drive them, operate them. Some of you are going to have them in your garages. Some of you aren't going to have them. You're just going to use them. But this fusion of technology and transportation is about ready to change the way we all move around and the way that goods and services move around as well. So, I want you all to think about what I said in the beginning. What's your personal goal? 5 years from now, what do you want to do? The world's changing around you. It's going to continue to change. 5 years from now, it's going to be changing even faster. I really want you to think about what's your personal goal. What do you want to do? Because the only guarantee is you're 5 years older, I hope. So with that, thank you all very much. I think we're bumping against the time. So thank you all very much.